Section 9.1 is on graphing quadratic functions. A quadratic function is a function that's in the form of y equals ax squared plus bx plus c, and a cannot equal 0. The shape of the graph of a quadratic function is a parabola, so it looks like this, or it can be going upside down and looks like this. It's symmetric about a vertical line that's called the axis of symmetry. So for this parabola here, the axis of symmetry is the pink dashed line, and you'll notice that it's symmetric about that line. If I were to fold it on that line, the left side would be right on top of the right side. The equation of this line is called the equation of the axis of symmetry, and it is x equals negative b over 2a. And you need to memorize that little formula. That's how we find the equation of that line. The axis of symmetry intersects the parabola at its vertex, and that is the highest or lowest point of the graph. So let's take a look at this one back here. So in black I have my parabola, I have my quadratic function. Pink is my axis of symmetry, so this point right here is going to be my vertex. And your vertex is either going to be the highest or the lowest point of the graph. If a, that is the number in front of x squared, is positive, greater than 0, then the parabola opens upward and the vertex is the lowest point, and it's called a minimum. If a is a negative number, if a is less than 0, then the parabola opens downward and the vertex is the maximum value. So we're going to take a look at a couple functions, and we're going to do these 7 things. First thing we're going to do is find the equation of the axis of symmetry. We're going to find the vertex, then determine whether the vertex is a maximum or a minimum value. We're going to find the y-intercept, make a table of values, graph the function, and then state the domain and range. So let's take a look at our first one here. I have y equals x squared plus 2x minus 1. I like to start by identifying a, b, and c. So a is the coefficient of x squared. In that case, this case it's 1. B is the coefficient of x, so that's 2. And c is the constant value all the way over on the right, and that's going to be a negative 1. So to find the equation of the axis of symmetry, I'm going to use the formula x equals negative b over 2a, and let's plug in those values. So b is 2, so I have negative 2 over 2 times a, which is 1, which gives me negative 2 over 2, or a negative 1. So my axis of symmetry is the equation x equals, oops, I forgot my negative, x equals negative 1. So that's going to be the vertical line that goes through the vertex about which the parabola will be symmetric. Now, to find the vertex, this is actually, this x value right here is the x of the vertex. To find the y value of the vertex, I'm going to plug it back into my original function here. So I have y equals, and let's plug in negative 1 for x, negative 1 squared plus 2 times negative 1 minus 1. That's going to give me a 1 minus 2 minus 1, or negative 2. So when x is negative 1, y is negative 2, so my vertex is the point negative 1, negative 2. The next thing I need to do is figure out whether it's a maximum, my vertex is a maximum or a minimum. To do that, I'm going to look at my value for a. So a equals 1, therefore a is greater than 0. So that means my parabola is going to look like this. It's going to be opening upward, and my vertex, this point down here, is going to be a minimum. So my vertex is the lowest value, or a minimum. Now, to find the y-intercept, okay, I'm going to let x equal 0. To find the y-intercept, let x equal 0, and then find y. So when I do that, I have y equals 0 squared, and I'm plugging this into my original function up there. 0 squared plus 2 times 0 minus 1. That's 0, that's 0. So my y-intercept is y equals -1. Okay. Now I need to make a table of values for my function. So to do that, I'll make a table that looks like this. And y is equal to x squared plus 2x minus 1. So I'm going to choose values of x, plug them into the center section, and then figure out what y is. Now remember, this parabola, this function, is going to look symmetric like this. So I'm going to choose, or make my vertex the center point of my table, and then I'm going to look for 2 values that are smaller and 2 values that are larger. So my vertex was -1, 2, -2, and I don't have to calculate that because I already did that. So I'm going to pick 2 values of x that are smaller than that, so -2 and -3, and then 2 values of x that are greater, 0 and 1. And I'm going to plug those into my function and see what I get for y values. So I'm going to plug in -3. -3 squared is 9, plus -3 times 2 is a -6, minus 1, so 9 minus 6 minus 1 gives me a +2. Plugging in -2 for x is going to give me a 4, plus a -4, and minus 1 is going to give me a -1. I've already plugged in -1 and I got a -2. Plugging in 0, I get 0 plus 0 minus 1 gives me a -1. And plugging in 1, 1 squared is 1, plus 2 times 1 minus 1 gives me 2. So that gives me the ordered pairs, -3, 2, -2, -1, -1, -2, 0, -1, and 1, 2. Notice in the y values, notice how in my table I have a -2 in the middle, and then on either side of the -2 I have -1s, and then beyond that I have 2s. That's exactly what I'm going to be looking for, is there should be symmetry in the y values that I get. If not, then you've done something wrong. Okay, so let's go ahead and graph this. So I have -3, 2, -2, -1, -1, -2, 0, -1. Notice there's my y-intercept and the point 1, 2. Okay, and the parabola goes like this. Make sure you put arrows on the end because it continues up infinitely, and arrows there. That wasn't a very good line. Let me try that again. That's a little bit better. Okay, so there's my graph that I got from my table of values, and then the last thing I need to do is state my domain and range. My domain is going to be all real numbers, and remember that means what can x be? X can be any number, so all real numbers. And my range is what y can be. Okay, well, looking at the graph here, y cannot be anything smaller than -2. Right here at my vertex, y is -2, and my graph only goes up from there. So my range is the set of all y such that y is greater than or equal to -2. And that's all 7 steps for graphing a quadratic function. Let's take a look at a second example here, and let's do the same thing. So I have y equals -3x squared plus 6x minus 1. Let's start by identifying a, b, and c. A is -3, b is 6, c is -1. Let's find our axis of symmetry. X equals -b over 2a, or x equals -6 over 2 times -3, which is -6 over -6, or 1. So my axis of symmetry is x equals 1. Remember, that's the equation of a line. That's a vertical line, so let's write it as an equation. Now to find my vertex, I'm going to plug in this 1 into my original function here. So y equals negative 3 times 1 squared plus 6 times 1 minus 1. 1 squared is 1 times negative 3 is negative 3 plus 6 minus 1, or my y is equal to 2. So that means my vertex is going to be the point 1, 2. Okay, since my a is negative 3, that means a is less than 0. So my graph is going to look like this. It's going to be opening downward, and my vertex here is going to be a maximum value because that's the highest point on the graph. Okay. My y-intercept is what I get when I plug in 0 for x. And if you haven't noticed, multiplying by 0, that's going to go away, that's going to go away. Basically, your y-intercept is whatever c is. So my y-intercept is negative 1. Okay, and now let's make a table of values. In my center column, I'll put what my function is, negative 3x squared plus 6x minus 1. Whoops, wasn't very straight. And y. And remember, you want to put your vertex as the center point in your table. So I'm going to make that my middle value. So my vertex was the point 1, 2. Pick two values smaller and two values larger. Okay, so when I plug in negative 1, this gets a little tricky now because negative 1, I have to square it first. That's going to give me a 1 times negative 3 gives me negative 3. Negative 1 times 6 is negative 6 minus 1. Negative 3 minus 6 minus 1 gives me a negative 10. 0, actually, this one isn't too hard. That's going to give me a 0 plus 0 minus 1 gives me a negative 1. Plugging in 2, square the 2 first. X squared, 2 squared is 4 times negative 3 is a negative 12. 2 times 6 is a positive 12 minus 1, and that gives me a negative 1. And that's really good because notice right above my vertex I have a negative 1 also, as it should be. And plugging in 3, 3 squared is 9 times negative 3 is negative 27. 3 times 6 is 18 minus 1, and that gives me a negative 10. So let's graph those points. So, I don't think I have a negative 10 on this one. I think my graph is too small. Okay, well, we'll put it down here. So negative 1, negative 10 is going to be somewhere down here. It's a little off of this graph. 0, negative 1, 1, 2, and 2, negative 1, and 3, negative 10. So my graph looks like this. Don't forget the arrows on the ends. Try not to make it quite as pointy at the top as I did on that one. Okay, and the last thing is my domain and range. My domain is going to be all real numbers. And my range is my y values. Let's look at the graph to figure that out. So notice that from the point where y equals 2, that's my greatest y value, it goes down from there. So my range is going to be the set of all y such that y is less than or equal to 2. So that's all of the parts of a quadratic function and how to graph it.